So this is the last video that I'm posting for you for March 24th for Kin 425. And this is going to be a summary of two papers that were, two journal articles that were retrieved by Claire and Serena. And these ones both involve the effects of muscle cooling, first of all, on force variability. And the second one had to do with muscle cooling on motor unit properties. And this is by the same research group. And so I'm going to try to summarize the important points from these articles in one whiteboard session. So both of these summaries are posted in the Blackboard system. So essentially what they found that with muscle cooling, the twitch response, so the twitch force response was altered. So I'm going to have force here on the y-axis. I'm going to have time, and I'm going to have an electrical stimulation here. So normally what you'd get is a response, a muscle contraction, and then relaxation. With cooling, what they found is that you get a prolonged contraction time, you get a lower force output, and then your relaxation time is also longer. So to summarize here, you have a lower force output in response to that electrical stimulation. You have a longer relaxation time. And you have a longer time to peak tension. Again, the dotted line represents the cold condition, and the solid line would represent our normal temperature condition. So just a reminder of what's happening inside the muscle to cause these changes. The longer time to peak tension would be caused by a slower actin-myosin binding. The lower force output would be caused by a weaker actin-myosin binding. And then the longer relaxation time would have to do with a slower pumping of the calcium back into the sarcoplasmic reticulum after contraction. So that was the effect of cooling from both papers on the twitch properties of the muscle. So the papers also looked at changes in motor unit recruitment with cooling. So with cooling, these are the changes that they found. So the first interesting change was they found that there was an increased, this is motor unit, MU stands for motor unit action potential duration. What that essentially means is that the conduction velocity of the action potential down the axon of the motor unit innervating the muscle fiber was slower. So the axon nerve conduction velocity or conduction velocity was slower. So it decreased with cooling. Now they also found that there was a decrease in motor unit action potential amplitude. And this just means that the motor unit action potential was weaker. So they found that with cooling, there were a couple of compensations that were made for these changes in motor unit activation. So the first compensation they found was that there was actually an increased motor unit number recruited. And this is to achieve the same force output as in a normal temperature condition. So they thought that this increased number of motor units recruited was to compensate for these changes. And they also found that there was an increased or an earlier, I'll say an earlier motor unit recruitment at low force outputs. So if they did a weak muscle contraction and they measured motor unit recruitment, it occurred earlier in the cooling condition. And again, they think that that's to compensate for these two changes. So that pretty much summarizes those last two papers. Again, those papers are posted on the Blackboard system, or the summaries for those papers are posted on the Blackboard system.